Hello, my name is Ben Seaton, and this is my capstone project for Bdan 310. Starting off with line one, we're going to see body data read Excel, and that's just going to load it into the data so I can start working with it. So it's going to run that. Just going to show it over here on our right in our environment panel. Moving on, we're going to build a linear regression model with this line. It's going to build it based on what it's in the parentheses. So we body fat, abdomen, weight, height, etc. So we're going to run that. Going to pop up down there. And if we run this, this is going to show the model and it's going to show the most statistically significant variables. So here we can see the R squared, significant codes, standard error, etc. Moving on, this line makes predictions using this linear model, and this line calculates how far off our predictions are on average, or the RMSE. And this next line is just gonna show us the RMSE. So we can see down here we have our RMSE, which is 4.410914. Moving on, we see something different. We see the tree model. It's going to build a decision tree, which is just going to be using the same variables. As you can see, the parentheses, body fat, abdomen, etc. And then this next line, R part dot plot tree model, is going to show us the actual decision tree. So here we see on the right, the decision tree is going to pop up. And then this next line, body data, it's going to actually show us using the data how accurate the predictions the decision tree is making are. This is going to show the RMSE value finally for the decision tree. So here we are, 4.296112. Now we're moving on to the loan application. So it's the same thing with this loan application's Excel sheet. It's just going to be loaded in under the read Excel. So now it's just loaded in and ready to use. This is going to turn the loan data into a format we can use because it's in the wrong form right now. It needs to be a factor and or like a categorical factor, and right now it's the opposite. So we're going to do the same for credit history. And then these are just making sure that the income columns are actually ready to use because they kept messing up, so I just had to make that work. And here we're going to see something completely different than we've seen before, which is the logarithmic model. And it's going to have everything within these parentheses, which is all new data. And it's going to create a logarithmic model, a regression model, which is going to predict if people can be approved for the loan. So start there. And then we saw before with the summary of the log model, that's actually what's going to show us the logarithmic model. So here, pull up that and it pops up down here. Giving us details about, how each variable will affect the population, as you can see. So credit history, it's just the estimate of where things will be at based on the average. And then coming back up here, loan data and predict. This is gonna predict the probability for approval that people are gonna have from this loan data. So we're gonna run that. And then this next line is actually going to turn them into either a yes or no answer. We're going to make it a lot easier to understand. And then this final line predicted how accurate the model actually was at predicting these loan results. So we're going to see here the accuracy was 0.845, which is almost 85%. Prediction, 31 no's. Okay. So yeah, this is our confusion matrix. Coming back up top, now we're going to do the exact same thing, but just for the decision tree. So we're going to see it pop up in our top right environment. Or see this pop up into the bottom right. This shows how the tree is going to split, to make the predictions. So you see that on the right we got the yes, and on the left we have the no's. And again, this is going to make the tree, have just yes or no predictions. And finally, we see fusion matrix, loan data, loan result. This is going to give us another confusion matrix, which is just going to show us how accurate the decision tree actually was. And again, we can see it's 85%. Thank you so much for your time and have a great day.